All right, everyone. Thank you for coming to my talk, How to Manage Releases Using Git Tags and Semantic Versioning. So my name is Mike Miles. My pronouns are he and him. I'm excited to be part of this conference today. For me, if you weren't listening to the conversation, it's morning for me where I am in the world. So I have my cup of coffee, but I'm excited to start my Friday with this. So I have an annotated version of this presentation, which is this bit.ly link down below, and it's actually the version I'm using. I was going to share my full screen, but Hopin is having some issues. I'm not able to share my full screen, so I can't actually do some live coding to show you how to do this, but I have everything annotated, so it's no problem. Just a bit about myself before we get into the meat of things. So again, my name is Mike Miles. I've been working as a professional web developer for just about 15 years now. Currently, I am the director of web development for MIT Sloan, which is the School of Management, part of the MIT, Massachusetts Institute of Technology. And so my role there is to manage the team of developers who's in charge of the main school website, which is mitsloan.mit.edu, and some other web properties as well. So we use semantic versioning and Git tags to manage our code base. So I'm excited to share this. I'm also the host of a podcast called Developing Up, which is focused on the non-technical side of being a developer. So everything you need to know about having career in web development, or not web development, but development, that's not about writing code. So it's everything else related to it, if you want to check that out. And if you just want to know more about me, I'm all over the internet. My handle is usually Mike Miles 86, such as on Slack, on Twitter, on GitHub. So you can find out more about me there if you're so inclined to do so. So what is a release? In the scope of this talk, a release is any time you're deploying code changes from your code base to your production environment, whatever your production environment is, right? That could be you're releasing a new package, maybe you're writing an NPM package, you're updating your website, you have an application you're building and you're releasing it, or a phone app and you're releasing that to your users, right? Anytime you're making changes that impact or alter how your functionality works, that's what we consider a release. So releases, in managing them, can get messy. The longer you work on a project, obviously the bigger the history of your project and the more releases you have. And so if you don't have a straightforward way for you or your team to indicate the degree of changes that have been made, one that doesn't inform your users if they're able to upgrade to the latest version of your release or use your latest version of your package, it's going to be harder for you if something breaks on your website to know back in your code history when you made certain amount of changes, and it'll take longer to then find the issue and fix it. And just when new people come onto your team or you join another team, if there's no release management in place, it's going to be harder for you to get up to date on the policies and practices to successfully manage your code. So what we're going to talk about today is how to use semantic versioning and the basics of semantic versioning, which is a numbering system used in software, and how you can use it on your project. Then we're going to talk about Git tags. So if you're using a Git repository to manage your code base, how you can mark certain states of your Git repository with what are called tags to mark them as some sort of significant changes in your code base. And then we're going to combine the two to talk about how you can create semantic releases using Git tags and semantic versioning together. And finally, just some general tips and helpful notes on how to create release notes that are informative for you, for your team, and if you have end users, them as well, to understand when you've created a release, what's changed and what they need to do to be able to upgrade, say, to that new version. So let's start with semantic versioning. Semantic versioning is a numbering schema. It's a concise way to indicate changes to your code base in the way you change the number indicates the degree of changes you've made to your project. And it's an industry adapted process. It's used by everybody. Oh, my animation's not right there, but it's used by React. It's used by every operating system you may use. You'll see a 3-digit number that tells the version of it. Your browsers all use semantic versioning to mark when there's been changes to their underlying code. And as well as any tools you might use, such as Git itself uses semantic versioning. A slightly different flavor of it, but it's still, they use the versioning number system to indicate the degree of changes. So the structure of semantic versioning, it follows this pattern. It's a major number, period, a minor number, period, and a patch number. Now, each one of these indicates a different degree of changes to your code base. So we'll start with patch, which is the most common updates you'll see. So patch update going from version 1.0.1 to 1.0.2, this indicates that there's been bug fixes or trivial updates like spelling mistakes or other little corrections, nothing that really affects functionality, but just changes to improve the system. Depending on the project, this could also indicate security fixes as well. Then you have the minor updates. So going from version 1.0.2 to 1.1.0. This indicates that there's been changes in functionality that is backwards compatible with the previous version. So this could be slight alterations to functionality, deprecation, but not removal of functionality, or even adding like new experimental functionality that's not required by the core system. And then major updates going from version 1.1.0 to version 2.0.0. This is breaking functionality changes. Could be complete rewrites of the architecture. It could be just complete rewriting or removal of functionality, complete changes to the code base. So you'll see these don't happen as often as you may notice when you have software that you're updating, like say your phone OS or your computer OS. The major updates don't really happen as often as the other two. And that's for good reason because they indicate major changes. The thing about versions in semantic versioning is they are set in stone. What this means is when you create a version of your code base, so you create a new patch release, for example, once you've released it into your production environment, you cannot change it. Now, technically, you can change it. There's ways to do that with scripts and whatnot. However, it's bad practice to do so because as soon as you release it, you need to assume one of your end users is already using that version. So if you were creating a patch release and you fix a couple bugs and you realize, oh, I forgot to include this one fix I wanted to include, you can't just squeeze that in and re-push out the state of your data of your code base. You have to create a new patch release. Again, that's because you have to assume as soon as it's out there, someone's already using it. So any new changes you add after you've created a release and you're ready to do a new release have to be their own individual releases. And because of this, when you're managing your own code base and using semantic versioning, you are responsible for double checking that your version numbers are correct before you do the release. So I'm just going to go back to the previous slide just to indicate, right, when you are thinking through, you're ready for your next release, you really have to compare the changes you've made in your code base since your previous release and determine which bucket they fit under, if it's major, minor, or a patch. As well as this could be if your project depends on third-party projects, right, NPM package or anything else that your software might rely on. If you're upgrading that version you're using of that external third party and they've gone through a minor update, that probably indicates that when you do your next release, you're going to need at least a minor update because it may affect how you've written your project code. So just things to keep in mind. So that's semantic versioning, 3 numbers, major, minor, patch, and they indicate a different degree of changes in your project, and everybody uses them. So let's talk about Git tags. Now, if you're using a Git repository to manage your code base, you may know when you make changes and you save them, you're creating a Git commit, right? So that's a certain state of your code base at that time. And those commits, they have long hash numbers. So what tags allow you to do is add basic human readable names to those commits and mark a commit as having some sort of significance in your code base. Now there's 2 types of tagging in Git. The first are lightweight tags. So this is just a basic name pointer to a commit. So you could say git tag and then the tag name. And if you wanted to, you could add a commit if you wanted to back tag commits. If you don't include the commit hash, it'll just use your head, which is your most current commit. So when you do this, what it is really helpful for is if you're in the middle of doing a lot of work and you are making commits and you mark them so that you can go back to them as you're still developing. I think earlier there was a talk on rebasing with Git. So this could be helpful. You could tag a bunch of commits to understand before you rebase to combine them all together where you've made significant changes, just as like notes to yourself. These are not recommended for using it as release tags, and we're going to talk about that in a little bit about why. But it's just a helpful way. So if you want to get back to a certain commit, you don't need to know the commit hash. You can just use the tag you've created to go back to that state. Annotated tags are the other versions of tagging in Git. Now it's basically the same syntax. You say git tag -a in your tag name, and then you do -m and you can provide an annotation message. The benefit of annotated tags is that they are full objects in the Git database. I'm not going to talk about the structure of the Git database bit today, but they create their own full objects instead of basically just references to commits. It can be checksummed. It will contain additional information about who created the tag. You'll have separate tag messages. And then if you're releasing like a public project, it can be signed and verified using GNU Privacy Guard. So you may see that with some projects when you download them, they say, check this hash to make sure this is a valid release. And so they do that using a method such as this. So the benefit of this is since they're full objects, they're better to track. And you do the same thing as you can see in this screenshot here, that you can just add the tag name and you can still reference that commit using that tag name. But then it's going to have all this additional information that you can use for references in the future. So now if you take annotated tags from Git and you name them using semantic versioning, that's what we're calling semantic releases, because you're marking your Git code base as having a significant degree of changes at a certain time on a certain commit, and you're indicating the degree of changes since the last release using semantic versioning. So it makes it really straightforward for you and your team or your end users to review the degree of changes in your Git repository and thus your project to know when major changes have occurred. So I think I just talked through this. Again, these are my annotated slides, so I usually don't have all these when I present. All right. So annotated tags or semantic releases are supported by many Git interfaces. If you use a GUI interface, obviously they're supported by the command line using the git tag command or the git log command to see them. If you use something, say like Git Kraken is a tool a lot of people use, you can see in this screenshot on the bottom left-hand corner with the red square around it, it highlights all the tags. And if you're using semantic versioning, you can easily compare the types of changes that have happened in your code base history. Or even if you're using like GitHub or GitLab or Bitbucket, they have releases and tag screens that you can check your tags. And again, it makes it really straightforward and easy for you or your end users to see what degrees of changes have been being made in your project. The benefits are also that it's supported by a lot of automated tools. If you use any CI workflow or plan to introduce it, like say config Circle CI, you can build out what are called workflows to trigger certain steps to help with deploying to your production environment based on the tagging pattern of semantic versioning. So here, this example of Circle CI, it'll run deploy to production when tags only match a V, then numbers, period, numbers, period, and numbers. So that's semantic versioning string. And this is supported by a lot of the automated tools that people use: Circle CI, Bitbucket, Travis, pretty much all the CI tools out there people use support marking, checking Git tags, and then you can follow a pattern of semantic versioning. So to create a semantic Git release, you create an annotated tag, use semantic versioning to name that tag, provide an annotation message, which we'll talk about shortly, push that tag to your remote repository, and then insert your deployment steps here, whatever they are for your system. It could be releasing it to your production server. It could be releasing a new version of your application, publishing to the package library you're part of, whatever that is. That's the steps you follow then. And you've created a new semantic release. So creating a semantic release tag using command line, it's that annotation tag command, git tag -a, your version number. The general practice is to prefix it with a V, which is English for version. So version 2.7.45, for example, and then a message. At the very least, you want to start with release and the release number to go with that tag message. Then you push it up to your remote environment using the tag name, and then whatever your production processes are from there. So now what? Now you want to create release notes, because the tag indicates the degree of changes that have been made to your code base using semantic versioning, but it doesn't tell anybody anything about what exactly has changed. So this is why it's important to include release notes with your releases, so that people understand the degree of changes from the number, and then they can read through what exactly has changed from your release notes without having to dig through your code base and check all the commits between the previous releases. You want to avoid the bare minimum of just saying release and the release number, because again, this is just indicating the degree of changes. It doesn't tell anybody anything about what has changed. So what is recommended you do is when you're doing a patch release, you at the very least provide a list of the bugs or the slight changes that have been made. So if you're using like a bug tracking, like an issue queue or something, you could prefix those with the issue numbers if you wanted to make it easy for people to understand. For a minor release, you want to do the list of changes to the functionality, plus any usage details about how to use the new functionality or what's changed with the existing functionality. And then for major releases, you want to list out the functionality that's been removed, functionality that's been added, and any important steps people need to know about upgrading to this new version. And these all feed into each other. So major release notes should also include any existing changes and any bug fixes. Minor releases should also include bug fixes as well, if those are included with it. This just provides a bare minimum helpful information for your users, for yourself, for your team. Now, for private projects, if no one's going to see your commit history, you could get by just getting a list of your commit messages, including them. That could suffice for your team, or just like internal ticket numbers from a ticketing system. And if you want to do that, an easy way to do it is getting a list of the commit message using a script, or using a git command, using git log with the pretty flag format modulus s, and then your last release tag, and then it could be head or another release or another commit, and that'll fetch just the messages from all the commits from that last release. And what you can do is you can take that, and then you can feed that into the message flag when you're creating your tag. So here, if I was creating a new tag, a new release, I could say git tag annotated the version number. Then for the message, I could do a subshell to run this command, and that would populate the message of my release with the very least with my commit messages. So that could be useful. My team uses this in our commit history because only we see the code base. But to go beyond that, some extra credit. Let me get all my slides working. There we go. Keep a changelog in your repo. So you'll see big projects do this. On the left here, you'll see this is a changelog for a project called Symfony. And so they keep a track of all their changes for their minor releases in this changelog file. And it means you can look into the code base, you can look at their changelog, and you can see the history of all the changes. Or if you have a public project, you could publish a page release notes. This is a screenshot from a framework I use a lot called Drupal. So whenever there's a release, they create a page on their website that explains the changes. And you'll see this happens for operating systems. It happens, I think, like TypeScript does this. They do like a blog post about it. So it's helpful for end users if you have a public project. To help you with managing your Git releases, your semantic releases, if you don't always want to remember, like if you're doing a patch release or a minor release, you should know if you're going to do a major release. But if you're not exactly sure what to go with, you can find tools and scripts out there in the marketplaces you use for your Git repository that can help automate that. So like GitHub Action, I know there's a GitHub Action out there that will do a semantic release, and it will check your commit history and look for keywords that you put in your commit notes to determine what type of release to go out. So you can find something like that. Or you could create your own bash script to help with your automated repeatable steps so that, again, you don't have to remember how to do it yourself, or you don't have to worry about someone doing the steps incorrectly or tagging the wrong release. So you could build your own scripts to help for you and your team and what they do. So like me and my team, we have a script that does this, which I've actually made publicly available, which I call Semtag Generator. It's at this GitHub repo. And so what it'll do is you can just say, in your Git repo, sh tag release, and then there's a bunch of flags you can pass. But if you don't pass anything, it'll do a patch release. It'll gather all your commit history, and it'll list it as the commit messages, and it'll tag it, and it'll even push it up to your remote repository for you. All right, so takeaways. Semantic versioning, industry standard for tracking releases. You have patch releases, so going from version 1.0.0 to 1.0.1, which indicates bug fixes or trivial changes. You have minor updates going from version 1.0.1 to 1.1.0. These are backwards compatible changes in functionality. And then you have major releases. These are breaking functionality changes going from version 1.1.0 to 2.0.0. Git tags allow you to mark a commit in your Git history as having some sort of significance. There's lightweight tags that are just really helpful for you when you're doing work. And there's annotated tags that create full-on Git database objects. Naming annotated tags with semantic version numbers is a simple and straightforward way to generate semantic releases with your code base so that you can keep track of the degree of changes and your end users can keep track of the degree of changes in your projects. And then creating release notes and including them somehow in your release or in your project is going to provide that detailed information that users need to know about what exactly has changed with your release and what they need to do to be able to update their system to use your project. All right, so I have some resources here for everybody. This presentation, the version I just showed, is available at this bit.ly link. That's bit.ly codebar22 sem tag. The semantic versioning website, semver.org, has a lot more detailed information about semantic versioning if you want to learn more about it. I know this is a really long link, but the Git documentation has information about creating Git tags and things you can do with that. So you can find that at the Git basic tagging URL. There's a helpful website called changelog.md, which provides guidelines on how to write really helpful change logs for your project instead of just relying on commit messages. And so they provide tips and formatting ideas on how to do that. And then that tag script that I use for my team, if you want to take a look at it and see if you could use it for your project, github.com/mikemiles86/semtag-generator. Feel free to take a look at it just to even get a better understanding of semantic versioning with Git. And that's it. I want to say thank you. So from Vicky asked, is going from version 1.0.1 to 1.0.2 for CSS changes as well as even minor ones? Yeah, you could do that, Vicky, if you wanted to. We do that in my project, actually. If there's if the font color is wrong for a header, because we do a website, if we're just changing a font color, we're going to push that up as a patch release. That's not going to be a minor release. You leave minor and major releases to changes in functionality. So if your CSS is, you're adding CSS animation that changes how something appears, maybe that would be a minor one. But if it's just adjustments and positioning, I would put that into patch releases unless it was like major re-architecture of your CSS.